Hi everyone, and welcome to another Geek Out. We are starting today with a very special guest from our partner NVIDIA, Michael Lang. I'm also joined by Chris Gassessa, who is the Solutions Engineering Manager North in Australia, and of course me, myself, Phoebe Go. I am a Principal Architect and I am in the Worldwide Technical Enablement team at NetApp. We're really glad you could join us. We have some really interesting topics to cover, artificial intelligence, deep learning, and machine learning. And yeah, please put your questions into the chat or the Q&A window. We'll get through as many of those as we can. We do have some great demos from Michael as well. So as they come through, please do put your thoughts and your questions into the chat. Other things, I guess, to keep in mind is that this is a 45-minute session. So we're going to go as deep as we can in that time. But if you have any questions following up as well, we will send out an email. So please do get in touch with your NetApp team. So introductions first. Chris Gassessa with the wonderful Geek Out background. I'm loving it. Who are you? What do you do? How can our attendees get in touch with you?
Oh, thanks, Phoebe. So yes, Chris Gassessa, the Solutions Engineering Manager here in Australia. Getting into contact with me, best place is probably LinkedIn. So not too many Gassessas, so G-A-C-E-S-A, and you'll probably find me.
Awesome. And Michael Lang, down in Melbourne, hopefully sunny Melbourne. Who are you? What do you do? And how can our attendees get in touch with you if they have any questions afterwards?
Yeah, look, thanks, Phoebe. So Michael Lang, I manage the Solutions Architecture team for APAC South, so all of Southeast Asia and ANZ. So basically geek in a suit most of the time. And look, LinkedIn is a great way to get to me, or milang@nvidia.com. Reach out, hey, happy to answer questions anytime for people.
So AI is a pretty big topic at the moment. We were just talking about it earlier, that it's kind of, as you said, orthogonal to traditional IT concepts. So I guess, what are you going to go through today? And, what do you think our audience will find interesting?
Actually, Phoebe, so just to interrupt, I think today we also need to be mindful of the fact that it's actually Michael's birthday. So, what better way to spend his birthday than his birthday? So, happy birthday, Michael.
Happy birthday.
Thanks, Chris. Love it.
This is your birthday present. Yeah. You get to hang out with us.
Hey, webinar time. Love talking. That's my thing, right? So all good. Thank you for the opportunity. So we do a lot of work with NetApp for a lot of customers. So yeah, all good. All good indeed.
Excellent.
So in terms of
what's AI? Why is NVIDIA involved? More importantly, I guess, and how does it work, and how can it work for us? I think is the number one question we have.
Yeah, so look, good question, and look, they're probably the most common questions we get from customers, and trying to understand, what AI is and how it works. It's a bit of a weird art at times, and we make jokes about data science, but it is a bit of an art as well. So let me try and walk through some of the what, where, hows, and whys, and we've got a chat window open here too. So any questions, please shoot them through. But obviously, artificial intelligence, data science, things like that, it's a really huge space. A couple of cover articles here from The Economist, one from a couple of years ago, data is the new oil. And we're now talking about, how chips can be, deployed for AI everywhere, the edge, phones, things like that. The thing about the first cover article there is really interesting because, we talk about data lakes a lot with customers. And what we hear is that customers have data swamps. And what they really want to do is really refine the data there and get some value out of it. So that's where AI comes in. And it's talking about changing businesses into more of an algorithmic business. So we talk a lot about, automation, but how can we make that smart? How can we help people to make decisions and adjunct them? So I'll go through that a bit and how that works. But probably the next biggest question I get is, hey, you work for NVIDIA, you guys do an awful lot of graphic stuff. And I make the joke, unashamedly, my mother still tells people that her son works for a gaming company. And yeah, we do gaming stuff. But on the enterprise side, we're sort of split into two hemispheres. One of those is obviously the professional graphics space, which we do a lot of work in. The other one's the high performance compute and AI space. And people say, well, graphics cards, compute, how does that sort of work? And this sort of comes back to 2008. Our founder came up with the concept of CUDA, so the unified compute language that we have. And in 2012, there was an AI scientist, a PhD research student called Alex, who was running through AI models and frameworks on his system. And they were taking weeks and months. And he said, now, I've got 4 cores in my CPU here, but I've got cards with thousands of cores that are computational enabled. What happens if I rewrite my program to work on those? And he dropped it down to a couple of days, and AlexNet is still a thing. He created his own deep neural network. And you can see here how the rise in GPU-based computing, if your code's GPU accelerated, is just massive. And this is really the massive parallelism. So I think the largest chip from Intel does about 56 cores now. AMD's up to about 64. One of our cards can have anywhere between 2,500 to 5,500 cores. And you put, 8 or 16 of those in a box, and all of a sudden you've got a massive compute capability. So this is where sort of we come into this. But it's not just about, an AI especially is not just about that sort of grunt. And apologies for the eye chart here, but really this is talking about all the software that is really enabled for either compute or AI deep learning, or even the analytics piece, which is more of a GPU-enabled big data piece, right? Not necessarily AI per se, but smart analytics. So it all comes down to the codes of the software that people use. And we've done a lot to really enable the software that's out there. So there's all these standard frameworks such as FFT is fast Fourier transform, for those who've got a maths background. And we CUDA enabled it, so QFFT and QBLAS and so on and so forth. So lots of different stuff that can work there. But obviously the focus today, yeah.
Yeah, sorry, man. So you mentioned earlier the whole neural network side of things. How have you seen artificial intelligence sort of change over the last 20 years?
Look, really good point. And I grew up as a kid on science fiction, talking a lot about, AI and, all that sort of stuff. But in the last few years, it's really the computational capabilities has allowed researchers to really explore the depth of software and what they can. And it's these neural nets, which are really, really the big piece, right? So that's when, when Alex is around doing his bits and pieces, that's when computational power became big enough to actually create machines that have scale to work on AI. So we'll look at this and let's compare and contrast the last 40 years to now. So for those of you out there who've done programming, you have my sympathies. I hate programming with a passion. It's just awful. And pain and struggles. But imagine if the boss said to you, hey, can you write a program to identify every car on the road? And the answer is, no, I'm going to go get a different job because it's just too hard, right? So every possible permutation and combination to identify every car from every angle and every bit of lighting, it's just too hard, right? But what deep learning does is it's based on the structure of the neural pathways we have in the brain. You can just see the picture there. You get an untrained neural network and you throw massively large amounts of data at this system. And what happens is the data does what we call backward and forward propagation through that neural network. And literally the software writes itself. So it actually learns how the elements are put together for this data set. So if you've got a massive data set with lots and lots of cars, it will learn what is a car. And by extension, everything that doesn't fit into that data set is not a car. Now, this is not always perfect. So for example, there were some scientists recently who are doing some training to identify dogs versus wolves. And wolves is, fantastic. They were identifying wolves at 100%. However, the problem with AI, and this is where we could talk about the black box challenge, is you can't ask the computer, well, why is that a car? It just goes, no, it's a car. So if you think about, for those of you who've got kids, kids look at chairs over, 3 or 4 years and they learn what a chair is by example. You try and describe a chair, okay, it's got 4 legs and it's made out of leather. Well, that could be a cow, right? So, or does it have arms? Does it not have arms? And all these bits and pieces. So AI can't tell you why something is. You can just say it is. So with the wolf example, the scientists thought they had it down pat. It wasn't actually identifying wolves. It was identifying snow in the background. So whenever it saw snow, every picture of a wolf had snow. Therefore, snow equals wolf. The computer couldn't tell you that. It was failing on the occasional pictures they had that didn't have snow. So, AI needs to be trained, and this is where data is unbelievably critical to this. So I'm going to keep coming back to data. As much as the software and everything is really important, but data is critical.
Okay. So once the learning has been done, then is that it? It's all finished and ready to go?
Well, as we're all in lifelong learning now, Chris, so, it's the same thing with AI as well, right? So here's where we see the 2 different hemispheres of AI. So on the left, we've got this training part I was just talking about. So you take an untrained neural network, you apply a massive data set to it, and picture of cats here because, hey, the internet. And then what you do is you extract that trained network, and let's call this the rough equivalent to, for example, an XML file. It's not exactly, but it'll be used for example here. And then you apply that on, quote, the edge. So I've got a couple of different cards that we have here, our supercomputer card on the left, and on the right-hand side, we've got our edge-based card, the T4, lighter, but suitable and perfectly designed for what we call inferencing. So inferencing is the application of that learning. So let's use an example here, one of my favorite ones. Lots of car manufacturers bring cars to Australia for testing because we've got lots of different environments here. Roads, on the sea, in the mountains, we've got snow, we've got desert. So last year, Volvo had a self-driving car out here in Australia, just outside of Canberra. Now, the Volvo self-driving cars have got something called LAD, or Large Animal Detection. And, you know, it was going down the road outside of Canberra, and it's sort of like, that's a cow, that's a horse, that's another cow. And then it saw a kangaroo and went, I have no idea what that is. Mic drop, I'm out. Pulled over, we're done, right? Because it just didn't know what it was. So, and hey, you know, we're unique in so many ways here in Australia. So Volvo got pictures and videos of kangaroos, took them back to Sweden, retrained the system with a larger data set, so the original plus the new stuff, put it into the LAD, and now it can drive around Australia and identify kangaroos. They're weird, but it knows where it is. So you design two different infrastructures here, but you continually relearn as you get more data, right? So this is how, as you've got the two hemispheres. And if we talk about a traditional IT solution, you have to design both these sets of infrastructure. Now, to be fair, the one on the right, the inferencing, that might be as little as a mobile phone, a small credit card sized device, whatever it may be. Or if you're still feeding data into your data center, so if you're a telco, for example, that still might be the same infrastructure on the left, just running different software and for inferencing purposes. So horses for courses, we do what we do. Now, of course, the question then comes up, all right, so we can identify cats, dogs, wolves, self-driving cars, the kangaroos, what else can we do? And there's quite a few different ways that AI can be used. Let me go through a couple of examples. So the first one is, you know, is something present or is it not present? So hot dog, not hot dog, cat, not cat. If we can identify multiple things, what are these things? What type of dog might it be? What type of food? You know, here we talk about, so one of the examples here is credit scoring. So, you know, what category do you fit into? In the medical space, segmentation is used an awful lot. So this is a case of, you know, if you have a tumor, so it's identified, detection, how big is it? What stage is it? You know, how many locations? We talk about prediction. So whether that be self-driving cars or, for example, pedestrians on roads, things like that, where are people going? What's the likely outcome? That one's also used in, there's one of our customers does neuroimaging in Sydney, and they're doing so neurological defects over time. If we take multiple snapshots of somebody's brain, how is a neurological disorder progressing over time? What can we predict? Therefore, what treatments do we use? This also comes down to recommendation engines. And these are quite popular, obviously, for, you know, hands up if you've done online shopping. That's gone from a fairly basic system to now some fairly complex recommendations around what you can do. And my favorite, natural language processing. So, you know, if we've got here the ability to say, for example, Baidu's got an engine that can do translation in real time across 16 different languages. And it's not just identifying an individual word, it's also about context. So here we have the ability, for example, for the ability to say hydraulic ram, which we all know what that is. That's fairly simple. That's an industrial piece. It doesn't get translated as water sheet. We know it's a mechanical equipment piece because of context. All right, so that's all good. Okay. So questions just come through. Oh, sorry. Go ahead.
Yeah, no, I was just going to say there is a question that just came through. So I'll let you address that one. So
yeah, so inferencing in terms of small form factor and embedded systems. So if you do a search on the web for NVIDIA Jetson or Jetson Xavier or Jetson TX2, we have boards that are small enough to fit inside drones, which are used for, well, for those of you into extreme sports, your drone can navigate through a forest and follow you on your bike or on your snowboard or things like that, or if you're kite surfing, it can zoom around you. And these are literally the size of a couple of credit cards. Of course, that has a certain capacity of scale, and we can go bigger than that if necessary as well, depending on what you want to do. But these things are already available today. So yeah, really good question there.
Yep, fantastic. And it's good to, if you can dive into a bit more detail on some of those examples, that'd be great. We've touched on a couple of them here, but let's have a look to see what we're talking about collectively within our customer base today.
Yeah, good. So, I mean, look, we've got a lot of use cases globally. My favorite one is medical research. So obviously, cancer, the critical thing here is to detect it and detect it early. But one of the problems is lack of trained radiologists. Whether we're talking in an industrialized country or a third world country, remote telehealth, things like this, it's a really, really big challenge. And of course, the great thing about machines here is we're not actually talking about replacing people, we're talking about augmenting skills. So machines don't get tired, they don't get bored, they don't get distracted, and they're available 24/7 to provide assistance to experienced radiologists. And of course, they don't miss things. So this is where we have something that is not machine only, it's machine in conjunction with human beings to assist in finding things. And of course, when we're sifting through large data sets, that's what machines do, and they do really, really well. So I use the example for neuroimaging that's happening in Sydney. There's other medical research around the organisations in Australia. There was one recently in the IVF space, and it was interesting. Another customer asked about that one, and okay, so what's the business impact here? And the answer was, by detection of quality embryos, there are over 200 children now born who wouldn't have been born previously due to quality of eggs and things like that. And you think, now that's pretty impressive, right? So, and that's a visual-based use case, so pretty powerful. Another one that I quite like, and this is actually a Melbourne-based organisation, is car sales. So I recently had to replace a car that was stolen, and you look around and you go, ooh, I like that car, and I have no idea what it is because I'm not a car guy. What do I do? So car sales has got this great thing in the app. You take a photo of the car, and it goes, I will identify the make, the model, the year, and I'll link you up with some that are for sale nearby. So this is really, really super powerful, right? Now, an odd outworking of this one, which is really weird, is because people have their cars on car sales, what some smart people have actually found is that you can get somebody's number plate and you can 3D print it. And you can do some interesting stuff. And there's an example of a tradie in Queensland. The cops rocked up on his door and said, all right, we're taking you in for your hundreds of speeding tickets. And he goes, I have no idea what you're talking about. And as it turns out, somebody had taken his number plate off car sales, used a similar car, not exactly the same, and 3D printed it. And this is now where license plate recognition is becoming more powerful, not just based on the license plate and optical character recognition, but make, model of vehicle to make sure that they've got all the data they need. And so this way, you're not actually giving somebody else a ticket by mistake. So, hey, AI for good, as far as I'm concerned.
That one with a don't try this at home, boys and girls.
Correct. It is illegal to 3D print a number plate, just to make it clear for the kids at home, right? So if we go into something a bit more complex where we might like to remove people a bit more from the loop, inspection, we're coming into summer in Australia, so inspection of infrastructure and power lines is a really, really big one. We've had a few fires here in Melbourne over the Victoria over the past couple of years because of infrastructure. So how do we do this at scale? How do we fly a drone over a site and check to see that things are stable, that they're valid? An example here is around maintenance of some site equipment, detecting for either heat or rust or cracks. This is being done for rail equipment and rolling stock, mining equipment, all sorts of stuff, whereby you can actually go through, do some quick analysis, and rather than human beings having to, look at every single frame, every single picture, we can do some quick analysis here to see what's going on. So that's, downtime, reducing downtime is a really, really big thing for organizations, and automating that is key.
Absolutely. We're having very similar conversations with another energy company as well. And the amount of time and money that they have, because otherwise they've got physical people walking around each of these sites inspecting poles and vegetation, all that sort of thing. And so to be able to utilise this for inspection purposes is going to be mind-blowingly better for them to do that.
Yeah, and look, this is also being extended into emergency services. So when little Timmy gets lost in the woods and stuck down a well, you send out a fleet of drones to create a line and go forward using forward-looking infrared or FLIR. And when it finds a hotspot, It finds little Timmy, sends back a location, and you can even send out drone packages now with, you know, what they call a virtual Saint Bernard. You know, so it's got the little pack of emergency equipment, and a little Timmy feels comfortable. They can do some video calls and that sort of stuff. So all these things are becoming super, super powerful. It's not just for following us around when we're doing extreme sports and stuff, which is quite cool.
I hope he's got the rum barrel underneath his
Correct, yeah. No alcohol for little Timmy's under 8, right? So that's a fair thing. And this is a really good one too. So I had to put through a couple of insurance claims recently for that car issue mentioned earlier. And one of the great things here is you think about insurance firms. So to be able to run through claims, and you can automate these to a degree, but sometimes they get a bit complex. So do you want to have a human being analysing both the easy and the complex claims? Or do you want to really focus that customer service on, hey, your claim's easy, simple, straightforward, bang, it's approved. And the ones the computer can't approve, not says no to, but just can't approve, they go to your humans for, you know, all the expertise and stuff they've done over the last several years. And they've got plenty of experience, and you've got great customer service for either a quick review or a really detailed human interaction for the complexity stuff. And what that does, happy customers, right? So and think about this after a flood event or a natural disaster, the ability to automatically process claims fast is just a huge thing to make people happy. So a great one, which is a text-based solution, not a visual one. And of course, the store of the future, the ability to do some shopping, put a few bits and pieces in your shopping basket, and the little cameras there on the side, as you put it in, it gets scanned and goes beep as you take it out again and put it back on the shelf, because I've got kids and they throw in the lollies and you've got to take them out again. It unscans it, you know. Still a few complexities around fruit and things like that, but your ability to throw them in a bag and just walk straight out. It does two things: it makes your experience awesome, and it also reduces theft in a really, really big way. So awesome solutions, right? And then, of course, we've got the ability to put telemetry into our cities. So most people think of, you know, video cameras as, you know, a smart city. However, all they do is capture video that maybe somebody's looking at, maybe they're not. But at the end of the day, it just sits on a sand somewhere. And until somebody goes back and reviews it, it's not data, it's just video. So here we have the ability to extract intelligence from video frames. And like the example here might be people counting. This is for town planning purposes, might be monitoring interactions of people, bikes, how many go through, counters, how are things used, all this sort of stuff. And that way smart decisions can be made and informed decisions. Otherwise, you're literally just guessing, you don't know. So let me take that one as a bit of an example here and show you something that we've done in our headquarters back in Santa Clara. So we have a fairly unusual building, and this is actually the underground car park. So yes, the building is in fact shaped like that. But what we've done is we've put a lot of instrumentation into our building. So the car park, so, you know, everybody hates the, you know, can't find a car park, is one open, is it not? Is the design working well? And we're actually building a second building. We're taking the smarts out of this car park and applying it into the other one. So we track things like where the electric cars go, how the charging stations are being used, people are coming in and out. We're trying to get rid of the boom gates so that the experience is a lot smoother. You know, obviously tracking vehicles that come through, you know, which are staff members, which are not staff members. Do we have enough visitor parking? All those things, trying to make the experience a whole lot better. And when you have, and so this is the cameras extracting data and this being put into a dashboard system. But if we have a look, we've got things like anomalies being detected. So a car came in and then left very, very fast. So what does that mean? And for example, outside of police headquarters, if that happens 5 times or somebody circles a block 5 or 6 times, what do we do about that? Here's the heat map. You can see where the popular spots are, different times of day. Of course, the irony is people can adjust their behavior based on this, you know, and be informed. Or you can link it up to a smart app and it can show you exactly where to go straight away to get a parking spot. I call that nirvana, right? That's the dream. That is the dream, right? So one day.
There's actually a question there, actually, Michael, and there's a question in chat, and I think I've summarized it. So if I haven't, please do send through another question. But the question that I think is really interesting is about the data collection process. And, you know, you mentioned that you're collecting this data from sources that you'd be using anyway, and then applying them to another building. But the challenge that there is in the industry is collecting that data, or the fact perhaps that there is, in order to get really good results, that you really do need huge sets of data. Is that what's been your experience talking with customers about that? And and how do they collect the data if it's, you know, if previously we've had to
Yep.
do it manually and now we're going to cameras and drones?
So this is a really big thing, and the question is actually highlighted specifically on you know, accessibility to data. So lots of startups do create a great tool, but if there's no data to leverage that behind it or to train a system, no point, right? So, you know, without data, you literally can't train the AI and you can't leverage it. Then you need the telemetry inbound of new data that you can make decisions based on. So the data is unbelievably critical, and it's actually the greatest hindrance. For example, in medical research, trying to get access to medical data is super, super hard, and it should be. It absolutely should be, right? So medical data needs to be protected. So we've actually put in place, we just announced today on Twitter that we've got a new AI system that can actually train on anonymous data or create anonymous data out of large data sets, things like that. It is a really, really big challenging solution, and we do need to have a good data set in the right format as well. So I'm going to go through a data lifecycle in just a minute, and this is actually key. But it's how you use that data, which is really, really important, right? So yeah, very good point actually. And if I go here, here's a video. Whoops, went one screen too far. So here's a video of a system. Now, most AI systems are inherently in the past have either been text-based or very, very basic web interfaces. So trying to make this easier to consume is really, really important, especially as more and more people try to get into data science. So here we've got an example. This is a tool called H2O.ai, which is designed to dashboard AI to make it simpler to use. And if we go and have a bit of a look here, there's a system where first thing it's trying to do here is trying to split the data. And you can see how you can put in place, by default, it's a 50-50 split. This is because you need data both for training, but also then to test your training on. So if you don't quite have enough data overall, you might want to trim that down and use some for each of those two purposes. And this tool makes that fairly simple for you in an automated fashion, right? The other thing, of course, you want to do with your data is once you've done some crunching on it, you want to then visualize it. So what are the tools I've got here to see what this looks like and how it works? And there's a whole bunch of different ways you can visualize depending on what your data is. So whether you're talking about genomics or, you know, traditional big data analytics, things like that, this has got the ability to check out outliers and things of that nature. So visualizing this is really, really key. Command line outputs are not necessarily awesome. And of course, you know, then we go into, okay, I'm gonna have to tweak and tune or rerun some bits and pieces. So this is where you've got the ability in this dashboard to what I call parameterize the IT interface to AI. So I'm going to change, for example, the number of epochs or runs that I go through my neural network, or how often I apply that, things like that. So these are different ways you can to apply this. And at the end of the day, what you really want to see is something like a bit of a dashboard overview. Here we're talking about tweaking the models, tweaking the coding, what you use. There was an example recently in a scientific magazine where some Python code was incorrectly created in that it worked differently on different platforms. And this goes to show the real importance of the code's got to be right, but the data's got to be right as well. Right? So this is quite a groovy dashboard, and for anybody who's got a statistical background, you might recognize some of the bits and pieces here around, you know, variables and iterations and things like that. And this is all obviously, you know, underlying on a GPU-enabled system. So data, absolutely critical in all cases here. And now this is interfacing into the science aspect, right? This is where a scientist might talk about hypotheses or what they're testing. Keeping in mind, if we talk about the pattern recognition, so is it a kangaroo, is it not a kangaroo, the system doesn't say yes or no, it comes up with a degree of probability. So it usually comes out with a 97% match or a 67% match. And so we've got to be very careful about how we do this, especially depending on what you're doing, for example, in the medical space. If you say, yeah, somebody's got cancer, give them these drugs, you want to be really sure of that, which is why we always talk about human augmented systems, not just systems replacing people in their entirety. So back to data, right? It's all back to the data. So this is all about the data lifecycle and talking about ingesting data. So there's a little box here in the beginning in between the two circles called ETL, extract, transform, load. This is where you do an awful lot of data preparation before you actually even put it into the training model. So life cycle of management here, and there's a reason the NetApp logo is on the screen, because it's all about managing the different data sets you have at the different speeds. So just think tiers and things like that, how you might have some in the cloud, some on the edge, core data systems where you replicate those back and forth, what data you move from the edge back to the data center, how this works for different models. Lots of different capabilities here around how you manage these things. So the data management piece and actually having access to that data, always critical. And of course, the compute piece. So NVIDIA's got a variety of different compute architectures that we use, depending on the scale you need. You can do this desk side, you can do it in the data center, you can do it in the cloud if you want, a few different ways. We have our DGX solutions, such as DGX Station, which is the shiny gold on the left. It's got 4 of our V100s and sits under your desk, and it's water cooled to keep it nice and quiet. And there's the data center boxes, which go from between 8 to 16 way. And of course, our stuff's available on pretty much leading OEMs, such as Cisco Kit or whatever you choose to use. But it's not just about the computational grunt in the boxes. It's also really key around the software. So when we come back to data scientists, the one thing they hate doing is preparing the infrastructure. So we've actually made the software really, really easy to consume. So we talk about AI models such as TensorFlow from Google, or Cafe2 from Facebook, MSTK from Microsoft, and a whole bunch of different frameworks. We make those available in GPU accelerated in our NVIDIA GPU cloud, which is a bit badly named. It's actually our cloud repository. And you can just do an API pull and yank those down to your machine, or Dockerized. And that way you can start your training, whether it's on a desktop or a massive server infrastructure, literally in minutes. So quite simple to do there. So at the IT layer, what would this look like? Ostensibly, you'd have some development of AI or training of AI in the data center. And you'd have the we call EGX, or our inferencing infrastructure, either in the data center or somewhere at the edge, or perhaps a combination of the two. Now, for people who get a bit, and this is quite a common IT thing, what does it look like? How do I build it? You're talking about a supercomputer infrastructure. We haven't done one of those before, and open source. Can we make this a bit easy? Yep, we absolutely can. So depending on the scale you want to go to, and this is at the upside of the scale, here we have some pre-canned stuff based on reference architecture from both NetApp and NVIDIA. This is our pods, the ONTAP AI pods, where we've got the NetApp AFF A800 FAS, in HA pair, obviously, for redundancy, some high-speed interconnect switches, and some NVIDIA DGX1s, or DGX2s, as one customer has recently deployed this. And obviously, latest and greatest, all the software, always up to date, and it's more importantly pre-sized and pre-scaled for large-scale AI training. But it doesn't have to be this big. We have some customers, as I said, who work on desk side, and other customers who've got smaller data center kit or bigger, depending on what you need to do. So a variety of different things.
Michael, what's the, oh, sorry, Chris, you go first. I was so excited. I was going to say, how many of your customers might build some of that pipeline, say in the cloud, and then move it to something like an ONTAP AI once they kind of validated their business case? Is that often the case, or do they tend to build an infrastructure that they're going to grow and keep growing, and know how they're going to size it?
Yeah, really good question, Phoebe. And a lot of it depends on the customer. So, obviously some customers have a cloud-first model, and that's fine. And if you want to just do some test and play, all these systems are available through both, VMs and APIs in the cloud. So it works, right? However, scaling out for learning often doesn't work that well in the cloud at cost base, but it depends on every customer. So if you're only doing iterative learning maybe once every 6 to 8 months, maybe that bursting is great. And you might buy some small equipment for your test and playground on-prem once you're doing that a bit more regularly. What often happens is a customer starts on one AI project and then grows that out over time to more. So, different things happen here. But we usually find, so if we look at, say, some architecture like this, probably the cutover is between probably around 9 months. If you're running this semi-permanently, after about 9 months, it's cost equivalent to a cloud solution. And of course, if you've got 3-year warranties on the equipment, which comes standard, then you've got just a bit over 2.5 years or 2 and a bit years. It's actually sort of paid for, as it were, electricity aside. So it really depends on the model that you want to go with. But when you start playing, the question is, how big do I need to go to start with? And cloud is a great way to explore that. Good question.
Yep, excellent. It's funny, we actually have been getting a lot of customers asking us how they get started. I mean, we've gone to what we can provide from a hardware perspective in a lot of the use cases. A lot of the customers have been coming to us just saying, we do store a lot of this data, but I don't really know where to start on how to monetize that really. So do you have some examples of what conversations you're having there too?
Yeah, so look, these sort of conversations are quite common. So, if I silo these conversations across 3 different spaces, so there's the C-level or the business line of business people, IT operations and architectural staff, and then the actual data scientists themselves. They all ask different things. When we have an IT conversation, it's often around, hey, non-standard, open source, GPU-enabled systems, high-performance compute, bit weird. What does that look like? How do we architect that? Which is why we refer to our reference designs, and that makes life easy to consume. If we talk about the business people, they're asking questions around, what are my use cases? Where do I proof of concept? How do I get that started? Where do I get the skills from? Finding data science people can be extremely hard and extremely expensive. So finding partners who work in that AI services space can be important. When we talk about the businesses and how they can monetize AI, the first question we ask is, what data sources do you have today that can be leveraged for this? And what are the type of problems that you currently have in your business? For example, in financial services, it may be fraud. In the example I gave before with insurance, it's about, perhaps it might be roadside assist and prediction, which is again in health, or it might be around, claims processing or things like that. So what does the business do, and how do we elevate the process to an algorithmic business if we can? What does that look like? And AI does not solve every single problem, and we may not be able to get the right services for a customer in that problem. It depends on the market space. As for the data scientists, the things we hear about them the most is, hey, we don't want to build our own kit. How do we get going easier and faster? So sometimes that's around what models you have available. How can you help IT deploy the kit? We had an example of a large financial services organization that was ready to go, and they bought some GPUs to go in one of their existing servers. And the data center people said, we're not equipped for that. It took 3 months to get the GPUs installed in the machines. And they're industry standard SKU from that vendor. So it was just around awareness. So we got involved there and helped with that deployment. The vendor got involved as well and made it a whole lot simpler, right? So, but also when customers want to get across this, we do workshops to assist with what the flow would be, discovery, things like that. And we've got training available as well for people who want to get in the data science space. I've got some of that coming up in November in Brisbane, and we do courses on a regular basis because the skills thing is usually the biggest inhibitor. In the early days, for example, of virtualization, hey, who's got some VMware skilled people you can bring into on site? You actually need to have those skills, and they're very expensive and very hard to get, which is why the AI services market is quite substantial and growing all the time. So yeah, good questions. So I'm probably going to pause there for a minute for questions from the field. That's sort of the quick and dirty spiel around AI to get your head around it. There's plenty of resources out there, both on the NetApp site and also the NVIDIA site around what is deep learning, how does it work, and how can it work in your business. So I encourage you to hop into those. And will we make this presentation available for people as well?
Absolutely. So we will have this recording available on YouTube on the Geek Out site as well. And
Terrific.
I mean, I've taken a couple of notes here of some really amazing things that you've said. So we'll send those out in our summary email. I guess I had a question. You touched on it, which is, what are some of those resources that somebody who is brand new to AI and really just wants to get their feet wet can understand it a little bit better? What can we go and find?
So one of my favorites is one of our guys gave a talk, and it's on YouTube. It's called Deep Learning Demystified. A guy by the name of Will Ramey, who's great to follow on Twitter. And if you Google that up, it's about an hour's worth. He's got a good voice to won't put you to sleep. And he worked through, in fact, a couple of similar slides here, but he goes through the whole process and really talks about, from a layperson's perspective, how it works, where the challenges are, you know, what it goes through, much deeper than this. And you can really get a good understanding of the process. For anybody who wants to create a deep learning solution, have a bit of a play, hop on our NVIDIA GPU Cloud, NGC site. There's some documentation. It shows you in about 15 different steps how to build a deep learning machine out of a PC and some graphics cards. And then you can download some sample data sets, which are in our tool set, and literally start playing with it in probably about an hour, including coffee and tea. But you know, there's plenty of good sources out there. And as I said, it depends on whether you're looking at this from a business perspective or a developer or data science person or an IT operations perspective as well. But as I said, if you go to the NetApp AI section or the NVIDIA AI and deep learning section, there's lots and lots of resources there, both video and text-based, to really help you get started on that journey as well.
Awesome. Thank you so much, Michael. And like I said, we will be putting this this presentation online, and we'll put those links up there as well if anybody's interested. A couple of notices. Oh, thank you. Yeah, that'd be fantastic. Thanks, Michael. Yeah, a couple of other notes just for our viewers. Obviously, if you need to if you'd like to get in touch with Michael on LinkedIn or his email address, milong@nvidia.com. I got that right. Also, yep. We are at NetApp Insight later this month. So if you are attending, there will be, there's always some really cool NVIDIA kit on the Insight Central floor. So do come and have a look and have a chat to the guys about how you can get that into your customers and into your businesses. And yeah, I think if there are any other further questions, please do send them through, and we'd be happy to forward them on to Michael for him to answer. So thank you so much for your time. Oh, absolutely, yes. The best questions in the chat. We'll be getting one of these amazing Data Visionary NetApp hoodies that Chris is holding up. Please come along to the next Geek Out, and as always, good questions get good rewards. So we look forward to seeing you there. Thanks a lot, everyone, and thanks for geeking out with us today. Phoebe, go.
Happy birthday, Michael.
Happy birthday,
Thank you.
Michael.
Thanks, everybody.